Today's webinar will focus on cost-effectively extending the life of rural potable water tanks. We will focus on actual projects and case studies where small towns were able to rehabilitate their aging water tanks versus replacing them, saving them millions of dollars. Just to give you a little background about Raven in case you are unfamiliar with them, Raven Lighting System develops and manufactures high-performance coatings and linings for the protection and rehabilitation of water, wastewater, and industrial infrastructure. They are currently celebrating over 30 years serving in these markets. They have an exclusive network of certified applicators who can apply their products based on their track record of success and commitment to provide their customers with the highest quality of work. With Raven, we have Ryan Bobman, a senior technical service specialist with over 13 years of experience with Raven Lighting Systems. Ryan is a NACE certified level 1 coatings inspector and a SSPC certified concrete coating inspector level 2. He trains both U.S. international certified applicators. We also have Randy Berthold, a regional manager with over 25 years of experience in protective coatings industry. Ryan is an 11-year member of NACE International and has served as the former vice chair of NACE St. Louis chapter, as well as the former chapter treasurer. He is also a NACE certified level 3 coatings inspector. And with that, I'm going to go ahead and turn the presentation over to Ryan.
Thank you, Drew. We're going to go ahead and start off with our first poll question. What are your biggest water storage challenges? Leaking, deterioration caused from cracking or rusting, contamination of the water, capital funding, or other? Looks like more than half of you guys chose deterioration caused from cracking and rusting, which is a common problem. Okay, we're going to go ahead and start with extending the life of your rural water tanks. This presentation is going to be divided up into 6 sections. We will start with an overview of the aging potable water storage tank challenges for rural water providers. Then we'll review 4 case studies where potable water tanks have been rehabilitated and protected using coatings and linings. The first case study will be about a steel water tank in Perry, Oklahoma, followed by a stone and cement water tank located above Telluride, Colorado. The third is a cement water tank located at Devil Tower National Park in Wyoming. The last will be 2 tanks in Wilson, Oklahoma that won Water and Waste Digest Project of the Year Award in 2015. We'll then wrap it up with a question and answer session. Our goal is to answer as many questions as possible as time permits. To make sure all questions are answered, we will also send out a follow-up email after the webinar presentation. The National Rural Water Association, with its affiliated state rural water associations, is the largest waste and water utility membership organization in the United States. They are a professional organization that supports rural and small water utilities throughout our nation. The rural water community represents 94% of the country's 50,000 plus community drinking water systems, which serves communities with fewer than 10,000 people. This is estimated that these communities have well over 100,000 potable water storage tanks, most of which were built between the 20s and 80s, using steel or concrete. Many of these older deteriorating tanks have been maintained improperly and require immediate attention to extend their service life before they deteriorate beyond repair and need to be replaced. This presents a major challenge for small and rural water communities, which operate on limited funding and sometimes rely solely on federal funding and grants to be able to maintain their tanks and infrastructure. So, why are these potable water storage tanks deteriorating? Besides environmental and chemical corrosion, it's simply out of sight, out of mind. Over time, steel tanks rust due to exposure to moisture and treatment chemicals. Concrete tanks corrode due to treatment chemicals and cracking caused by movement. Sometimes freeze-thaw cycles will affect them. These eventually result in structural instability, leaking, which wastes our precious water resources and costs rural water communities lots of money. The biggest question for rural water communities is, do we replace or rehabilitate a water storage tank at the end of its design life? The cost to replace a failing water tank is expensive, ranging between $2 to $6 per gallon of the storage capacity. For example, a new storage tank that's 200,000 gallons could cost just over $1 million. Plus, that doesn't include the cost of demolishing the old tank and site improvements for the new. Tank rehabilitations cost between 10 to 25% of the new construction. Additionally, rehabilitation can generally be done with a much smaller disturbance to the community environment while improving water quality and service. The key is to choose the correct rehabilitation system and have it installed by experienced, highly trained, and reputable contractors. This will allow for a cost-effective life extension of the tank. Also allows rural communities time to secure funding for future replacement projects. All right, time for our second question. How many end-of-life cycle storage tanks does your town have? 1, 2 to 5, 5 to 10, over 10, or none? Looks like it's kind of widespread. We're getting anywhere from 1 to 5 is the most common. Okay, now for the fun part. Let's get into the case studies. I'm going to start our case study discussion with Perry, Oklahoma. Perry is a small rural town located in north central Oklahoma with a population just over 5,000 residents. In June of 2016, Raven certified applicator WT Energy was contracted to recoat the entire exterior and interior of the town's water tank using products supplied by Raven Lining Systems. The roughly 7-year-old exterior coating had begun to break down, crack, and peel off quickly with exposure to sunlight and the elements. It appeared that the previous coating was applied very thin with poor surface prep, which resulted in a short coating service life. The current exterior coating system was in very poor condition. The coating used had most likely been a highly solvented epoxy coating applied at 4 to 5 mils thick with little to no surface prep. This type of coating system had been applied to the tank several times over years with very poor results. The existing interior lining was applied at an inconsistent thickness over subpar surface prep. As you can see from the photo, this resulted in premature rusting, staining, chipping, delamination. There were also large pits on the interior surface. From the photo, you'll even see the middle one is an unrepaired adhesion test. We've got multiple flanking of the exterior coating. Now let's stress, this is not the norm. It even appeared that the previous applicator coated over existing coatings, which is usually you're going to want to move, especially on the interior, remove all the coating. The existing interior lining had to be removed by abrasive blasting to a near white finish, then cleaned. A high build hybrid of polyurethane lining was chosen to provide a single coat application over the heavily pitted surface. Shown in the lower middle photo is what I'm talking about with being pitted areas. The chosen Aquataflex 506 lining is an NSF 61 certified product for contact with potable water. Cures to the touch in less than a minute, can be spray applied over 80 mils thick directly to a steel substrate once it is prepared. And this product also has 70% elongation to help with future cracking and impacts. The surface preparation on the outside of the tank was done by sweep blasting the surface to remove any loosely adhered coatings. All rust spots were taken down to a near white metal surface, providing a profile that the new coating could bond to. The selected exterior system was an 8 to 12 mil coat of a quad epoxy AQ90, a high solids epoxy that was roller applied to the exterior of the tank. This high solids epoxy was used to protect the tank from future corrosion. Then Raven 545, which is a moisture cured urethane, was roller applied at 5 to 8 mils thick over the epoxy coat to provide UV protection. Once completed, the district welcomed the change from a traditional thin mill coating that was being recoated every roughly 7 years to a high performance, high build coating with an extended service life that can reach up to 30 years. Perry received benefits from this rehabilitation. The cost to construct a new tank was estimated to be at $500,000. This did not include demolition or site preparation. The cost for this rehabilitation, which included interior and exterior coating, was $122,000, resulting in a net savings of $378,000. Some of the benefits that they achieved were water retention. They didn't lose anymore. Increased water quality for the community. And they installed a 20-plus life cycle coating, so they're going to be downtimes minimized. Okay, now for one of my favorites. Case study number 2 is Telluride, Colorado. 500 feet above Telluride, Colorado sits two 260,000-gallon water storage tanks. These tanks are below ground, hidden out of view from the town below. You would never know they were there. These tanks were built somewhere between 1920 and 1930. With very little information available, the city initially thought the tanks were constructed entirely of concrete. These tanks are very old and leaking. Being in a remote location, it had difficult access, and really the only choice on this one was to rehabilitate. There were 2 tanks that we're going to talk about. The first is going to be the west tank. This is the one that was currently rehabbed. The second tank is out for future rehabilitation. At some point in the west tank's life, it had been coated with a gunite product up to 3 inches thick. Unfortunately, the west tank continued to leak excessively, and in the 70s, a Hypalon liner was installed over the gunite. After 40 years of service, the Hypalon liner was found to be leaking over 2 million gallons a year. The cost to replace both tanks and the extensive road work to get the equipment up the mountain would have been over $4 million. The town would also be without half of its water supply during the demolition of the construction. It was decided in 2015, after an inspection of the tank, that the old liner needed to be removed, the tank repaired, and a new lining system installed. Once the old liner had been removed, large portions of the gunite fell off the wall and hollow spots were found. This revealed that the upper 4 feet of the wall was stacked stone with missing mortar. As you can see from the pictures, this was quite a surprise for us on site. No one knew that we were going to end up with a stacked stone until we were actually inside beginning the cleaning process. The more we cleaned, the more gunite fell off the wall, revealing the stacked stone. From what we could tell with talking with the city, they had a penetration at the bottom of the tank. So we're assuming the bottom 4 foot of the tank was the original tank with poured in place concrete. Then they began, sometime in the 50s, they thought they added the stacked stone wall with the roof. Once we removed all the hollow spots, the thorough cleaning was done with a high pressure water. And then cement repairs of the structure started. Raven certified applicator Global Linings chose to fill all voids with a Raven 760 polymer modified cement repair material. As you can tell in the top left picture shows large holes at the end of the roof support beams that had to be filled along with 2 pipe penetrations. These and all the other surface defects were repaired using the 760 polymer modified cement. Once all repairs had been cured, a penetrating epoxy primer was applied in 2 coats to seal and minimize off-gassing. Because of the drastic amount of movement that this structure saw over the past 90 years, we chose to use a geotextile fabric saturated into the first coat of polyurethane. What you're looking at on the picture is after the base coat was put on with the geo fabric inlaid. What that allowed for was if there was drastic movement, you would have a separation in between the coats, and that geotextile would stay in place, adhering to the final top coat. With the fabric inlaid throughout the tank, a Aquataflex 506, which is an NSF 61 potable water approved flexible polyurethane liner, was applied at a minimum of 125 mils. This application is considered a semi-adhered watertight flexible liner. The exterior tank roof was coated with the same product to seal it from leaking dirty water and debris into the tank, as well as acting as a barrier coat for corrosion prevention. Drew Lloyd, Telluride's town engineer, stated, once the project was completed, that the town was very happy with application of the lining products and workmanship under the very difficult access conditions by the contractor, along with the performance of the lining systems to date. Telluride received great benefits from this project. Not only did it estimated the cost was going to be $1 million per tank, the rehabilitation only ran a little less than a quarter of that. Their net savings came out to being just shy of $800,000. Some of the benefits that they achieved were they did not have any interruption of the hiking trail. Being a resort community, that was one of the big summer projects they had, is they had the hiking trails filled and didn't want to disturb any of the hiking trails. They had little to no disturbance to the community. They received reduced treatment costs by sealing the tanks and leaks. The water quality protection by the sealing the tank roofs increased and minimized their use of chemicals. Now I'm going to go ahead and turn this over to Randy. He's going to cover you Devil's Tower and Wilson, Oklahoma case studies.
Thanks, Ryan. Case study number 3, we're going to talk about Devil's Tower water tank. This project is located in northeast Wyoming, in Hewitt, Wyoming. This project is located in the United States National Park Service, which obviously starts some pretty complications right there with the rules and regulations. This was an underground concrete tank at 50,000 gallons capacity. It was located approximately 500 foot above the maintenance area of the Park Service and approximately halfway up the side of a mountain at the foot of Devil's Tower itself. If you look at the picture, you'll see coming right at the foot of this Devil's Tower itself. It's a 50,000 gallon concrete water tank built approximately 70 years ago to service both areas, including the campsite restrooms, the fire hydrants, the fire suppression systems, the entire campsite or the entire facility, the visitor centers, and the maintenance area below. This tank was showing signs of mild to moderate corrosion during the inspection on the concrete walls. It also had cracking on the concrete floor, which were thought to be leaking. Initial estimates to replace this old tank with a new structure was over $1 million due to the difficult location of the tank, disruption to the national park by the road renovation to get the large equipment up the hill to build the tank, and really just following the United States National Park Service guidelines throughout the new build process. Another big curveball concern, the Park Service didn't want to be out of the tanks any more than about a week's time. There obviously wasn't room for the time frame to build a new tank in that short amount of time frame. So with all that in mind, and due to the complications and cost and the time frame they were requesting, installing a lining system in the existing tank was the best option. Car Coatings, a Raven certified applicator from Belfouche, South Dakota, was selected by the general contractor, Bear Construction, to install the lining system. The products chosen were Raven 760 high performance polymer concrete to fill all the bug holes up to ½ inch deep, Raven 171 fast set, which is 100% solids penetrating epoxy primer, and a Quadaflex 506, which is 100% solids elastomeric hybrid polyurethane applied at 100 mils dry film thickness. The tank walls, floor, ceiling, and beams were abrasive blasted to a CSP5 profile. As you can see on the picture on the upper right, the abrasive blasting revealed imperfections up to 1 inch deep. What you're looking at is a quarter that's jammed into one of the bug holes to show how deep actually it is. And on the bottom right, the picture kind of shows after the abrasive blasting was completed, the spent abrasive that was there, and pretty nice illustration there. To address the cracks present, if you notice on the picture on the left, there was a crack, a pretty significant crack on the floor. A flexible hand-applied fluid membrane was applied inside and onto the crack, up to about 2 to 3 inches on either side of the crack. While that liquid membrane was wet, a 9-ounce fiberglass mat cut to size was placed over the crack to bridge it, and then completely saturated with the liquid membrane and left to dry. This worked as kind of basically a bridge gap on that crack for future movement. Approximately 2 hours after the epoxy mortar was used, if you notice the picture before, the guy was applying the mortar to fill all the bug holes, 100% solid penetrating epoxy primer, the Raven 171 fast set, was applied by roller at 6 to 10 mils dry film thickness over the entire surface. The epoxy primer was used to lessen the outgassing of the finish coat of the polyurethane that was going to be applied soon. The epoxy primer was allowed to cure overnight just because of timing of the project itself before the polyurethane lining was applied. The following morning, the Quadaflex 506 polyurethane was applied by heated plural component airless equipment at 100 mils dry film thickness over the entire surface. Approximately 4 hours after the application of the urethane lining install, the entire surface was checked for pinholes and holidays by high voltage spark testing per ASTM D4787. Once those were all repaired, the tank was sanitized with potable water storage and placed back into service immediately. One of the big benefits of that system that was selected. So picture now of the tank itself. Looking at the beams, the picture's actually sideways in there, but the idea is the idea. It was a monolithic coating system. Turned out very well. Big success. So looking at the analysis of this entire project, cost to replace this project new was really given to us at $650,000 plus the difficult site work up the hill and all the things that added up to be over $1 million. But $650,000 was the initial bid. Cost to rehab this project was $99,000, repairing the cracks and installing the system. Over $500,000 savings. Additional savings and benefits. Minimal disruption to the environment and the national park itself. There was a National Park Service monitor employee there the entire time. Could have been problems there. Fast return to service for the fire system and the potable water. Now they have a high-performance flexible coating for future freeze-thaw movement of the tank itself and improved drinking water quality now that the surfaces have got a fresh new surface and it's clean. Moving on to case study number 4 in Wilson, Oklahoma. Wilson, Oklahoma is a small town right on the border of Texas and southern Oklahoma. Concrete storage tanks, above ground storage tanks. 2 of them were rehab with a polyurea system. The condition of these tanks were very poor. One of the tanks was shut down, leaking, pretty in bad shape. So in the town of 1,700 residents, Wilson, Oklahoma's potable water is supplied from wells and has stored in 4 of these 80,000-gallon concrete tanks that were built in the 1930s. If you look at the picture, the one on the left is obviously this picture of one of the tanks of the roof itself. It gives you an indication of what all 4 tanks look like. Inside, you see the severe deterioration where there's actually rebar showing and falling itself, or bad shape. 2 of these 4 80,000-gallon tanks were badly deteriorated, resulting in the explosive rebar, like we just said. One of these tanks were so bad it was taken out of commission due to the excessive leaking, which required the town to spend $4,000 a month to purchase water from a neighboring town in order to meet their water supply demand. Town council realized they need to make a quick decision to either replace these clear well tanks, which would cost over $1 million, or install a lining repair system. Because installing a lining would be much less expensive and much quicker versus a full tank replacement, it was decided to move forward with installing a lining on these two tanks. Raven certified applicator WT Energy was hired as the contractor for the project. This contractor and the coating manufacturer, us, evaluated the challenge and recommended rehabilitating these clear tanks with an NSF approved 100% solids elastomeric polyurea lining specification designed specifically for the needs of these two tanks. Looking at these pictures, the inside walls were covered with a thick layer of calcite, which is calcium carbonate that had been built up for the past 80 years of this harsh well water that had to be removed, the coating system to bond properly. Calcite had to be removed along with all the deteriorated concrete before the lining system installation. And the picture on the right shows the exposed rebar and the calcite, and all that concrete was really loose right there around that rebar. Another challenge was the extreme cold weather during the project start, with temperatures fluctuating between 20 and 50 degrees Fahrenheit when this project was going to be done. The chosen lining system needed the ability to be both applied and cured in these cold temperature ranges. The applicator repaired the surface by abrasive blasting to remove the calcite buildup and the deteriorated concrete. The walls were then prepared using a cementitious mortar to build back the extensive deterioration and restore structural integrity of the original structure. Again, back to due to the extreme weather conditions of the project, a low temperature version of 100% solids penetrating epoxy primer was chosen because it was a blush resistant material and used to reduce the outgassing of the polyurea top coat. Picture in the bottom left shows the guy in the process of priming the surface. He's wearing a Carhartt and a coverall. I mean, it was really cold during that time. Picture on the right, obviously in the middle of the priming process. So going to the final step, which was to apply the polyurea lining at 80 to 100 mils dry film thickness applied by the plural component airless equipment. Pictures kind of show the progress, project in progress, right before they started checking holiday detection. As a quality control, they're going to ensure they had a monolithic lining. WT Energy did check the entire surface using high voltage spark testing, again with ASTM D4787, and made any necessary repairs on the holidays located. These are pictures of the finished product. Turned out really well. I mean, you can barely tell where the concrete was actually placed. This is after they fixed all the holiday detection and right before they put the tank right back into service. Project was completed on time and within budget, always a good thing. According to Buddy Way, the president of WT Energy, quote, "The town of Wilson needed to find a way to repair the water tanks or build new ones. We were able to provide a high-quality, cost-effective engineered solution to provide a long-term fix of the existing tanks for the city. It was a big success for everyone involved." Next picture shows the outside of the tank. While they were there, kind of a thing, they went ahead and did a quick shower blast of the surface and primed and coated the outside of the tank just so there's no water infiltration to come through a lot of the cracks that were on the roof of this concrete structure. So breakdown of the benefit analysis. Estimate to cost to replace new is $1.4 million, not even including the major demolition work to remove the existing tanks and site work. Cost to rehabilitate was $140,000. Complete interior reline. So net savings of $1.25 million plus. Additional benefits on this situation. Earlier we talked about replacing at the buy excess water. One of these tanks were taken out of the service a couple of years ago, cost them $4,000 a month to buy water from an outside source. So in 10 years, that's nearly a $500,000 savings they would have had. They've seen that. Second benefit, they placed one of these tanks obviously back into service and increased the capacity. Third, they were able to improve the drinking water quality by a brand new lining system on both these tanks. And another side note is Mayor Frank Schaaf saved the taxpayers a lot of money and came out looking like a hero because he did just that with his involvement with this project. Quote from Mayor Schaaf was, "Thanks to WT Energy and the chosen lining system, the city of Wilson was able to repair the tanks for $140,000, which saved us $1.26 million savings for the city." On top of the capital savings, the town will be able to realize, again, $48,000 a year by not having to buy water from an outside source. So the summary of all this rehabilitation, these projects we've been talking about, end-of-life tanks can be successfully rehabilitated more effectively than replacing. Hopefully, if you enjoyed learning about this Perry, Oklahoma, Telluride, Devil's Tower, and the Wilson, Oklahoma projects, cost-effectively fix their what we call end-of-life water tank issues. These communities save their towns a lot of money while improving their water quality and service to their customers. So 3 major takeaways from the webinar we'd like to address. End-of-life tanks, as we call it, can be successfully rehabilitated with a lot less cost than replacing them. In most cases, or many cases, these tanks can be saved with a lot less cost than by scrapping and building new. Second, rural communities can realize additional benefits through renovating their existing water tanks. The time savings itself is huge, and obviously improved operation of the tank itself. Obviously, when you're in the middle of rehabbing these tanks, all the other issues get fixed, valves, piping along the while it's being fixed in the first place. More importantly, I think the most important thing we want to talk to you about is choose a proven performance lining system based on the needs of the actual project itself. Also, choose a proven, experienced coating contractor to install the lining system to ensure the project will be done correctly and last for many years. This time we're going to look at the submitted questions we've had come in while we've been presenting this.
Sure. I can answer one. We've gotten a couple of questions about the slides that were used throughout this presentation, and yes, we'll be sending those out early next week to everyone who registered, so you'll get a copy of the slides as well as a link to the recording of this webinar if you wanted to go back and look at it. So one question we got in, I guess, one person asked, is there a warranty on these types of installations? What does that consist of as far as materials and labor?
Our standard warranty is going to be a 1-year warranty for material. Depending on the situation for each individual tank, that warranty can be extended. And that's going to be where you're going to go with that one is you're going to contact your local sales representative. He'll be able to determine if they can increase that warranty. Okay, I've got a question here. One of the questions is, why did we coat the roof in Wilson, Oklahoma, the exterior roof coating on that one? That was just to make it watertight. That came in after the fact. They wanted to go ahead and coat the exterior of it. It had a few cracks, so they wanted to seal the tank up on the outside. Really, it was more of a cosmetic issue. That roof drained good enough that there wasn't standing water, any infiltration coming into the tank, so they went ahead and coated it for aesthetic reasons.
Another question came in, what type of contractors can apply these products? It's a good general question. Really, only specialty coating contractors with experience with rural component spray equipment that have been trained and certified by their supplier, the coating manufacturer, should really be hired to apply these products. Another question, is a primer needed for the exterior tank coatings? It's always best, especially if we're going to specify abrasive blasting existing coatings off. A couple of reasons. I mean, the epoxy primer is what you typically see used for the corrosion protection, and also can be used as what they call a blast hold primer in many cases to prevent flash rusting. Once you blast it down to a commercial or a nearby blast, when exposed to the elements, it's going to start rusting right away, so we don't put some kind of a hold primer to keep the steel from flash rusting. Typically, you put on an aliphatic urethane on top of the epoxy primer within the recoat window to give it a UV protection.
Okay. We've got one here where someone's asking that we made a point to state that some of the quad epoxy coatings were NSF 61 listed. Are the Raven coatings NSF listed? We divide ours up into 2 different ones. Our Raven coatings are typically used in wastewater situations. Those regularly are not NSF rated. Our quad epoxy and Aquata Flex typically are NSF rated. If you have some particular questions on individual products, you can contact us or you can look on NSF's website.
Question is, how long will these lining systems last? That's a good question. You know, we've seen lining systems last 30 to 50 years on epoxy systems, depending on the system itself. Properly installed polymer lining systems would yield at least a 15-year service life, extending well past 30 years on many instances. We typically see the epoxy linings last 30 to 40 years, even plus, on concrete and steel. Urethanes, not quite as long as a life expectancy, but they're also kind of used from strength and subject a bit, but can be used on above ground structures where there's going to be movement and cracks in the concrete. So both of them have their place.
On what type of environmental conditions can be accommodated during the coating application, such as heat and cold? On an epoxy side, you're going to be limited by the temperature. Minimum application temperature on an epoxy is typically going to be around 40 degrees Fahrenheit. Minimum temperature on a urethane, you can range that down into below freezing, 20 degrees, can easily be accommodated. Different situations, different products can go lower than that. High temperature side on epoxy is going to be around 100, 120, a range there depending on if it's shaded or direct in contact with heat, sun.
What is an estimated cost for installing these lining systems? That really depends on the system specified, the project, where it's located. You know, cost is very labor dependent too. So, you know, a metropolitan area versus a rural, that can really range. But I'll tell you, just to give an answer here, anywhere from $15 to $30 a square foot on a typical high build urethane or epoxy system on concrete. Steel, it might be a little bit less, but it's going to be in that same realm. Hard question to answer, but I would tell you $13 to $30, depending on the normal project and average size.
Okay, one here. Someone's asking if the tanks in Wilson, Oklahoma were wood. No, what you're seeing in those pictures are just the form boards. Yeah. They're spaced out about every 6 inches, makes it look like it could be a wood tank, but they were concrete tanks in Wilson.
Nobody asked if we saw any Martians at the Devil's Tower like Close Encounters. No, we did not.
There's one here that Raven has the smallest tank size certification. On some of our products, we can go down to 5-gallon tanks. Other ones are going to be larger than that. So it's going to be, you're going to want to check on a product basis on how small that container can go. One here is if a system takes an end-of-line tank and repairs it with one of these systems presented, what is the new life expectancy of the tank? With annual inspections and stuff, you're going to be in that range of the 20-year. You're going to extend that out to the life of the coating. With the protection of the coating, that's going to protect your substrate, whether it's concrete or steel, and give you the life expectancy of the coating. What you do want to make sure is that structure is stable. If you're letting it go too far where it's rusting, the pits are going all the way through the steel tanks, you're going to have to make that judgment whether or not it's feasible to weld in those holes, repair the tank. A concrete tank, you want to make sure it's stable. If it's deteriorated, you can repair the deterioration as long as the tank is stable.
Another question came in, when is it or not feasible or cost benefit to install lining on a project? I guess the thought there would be the structure is no longer structurally sound or safe, may not be feasible and really can't be saved by a protective lining. Steel, obviously, if you got many rust through areas, concrete, excessive cracking movement. Really, that's kind of an engineering call to see if the structure's still sound in the first place. So,
how many years did this rehab add to the life of the Devil's Tower tank? That one it did add a 20-year life expectancy on it with the urethanes. And then we also, the question goes on to if we have any long-term info on your rehabs, for example, 20 years ago. We have historical case studies on our website at ravenlining.com. Those case studies are going to go back. We've got some that go back 20 years. Some of those are starting off with as simple as a manhole being epoxy linings. We've got large structures, clarifiers with epoxy. The urethanes, we don't have a whole lot of long-term case histories that go back to 20 years.
So question is, have you ever performed any work in California? Yeah, we have certified applicators throughout the state, and go to our website. There's quite a few case histories on California, and most all other states across North America, United States, and into Canada. So yes, we have performed quite a bit of work in California. How did you sanitize these tanks after rehabilitation before use? There's a WWA standard on a percentage of bleach that's used to sanitize the tank. If you like, give me a call or call in here. I can get you the exact answer. That was done by the contractor kind of after we'd already left, honestly. But an AWWA standard on the percentage of bleach used to scour or rinse the area before you put it back into potable water service.
Does the applicator have to be a certified Raven? Yes, we sell 2 certified applicators. What that allows us to do is go out and do yearly visits, recertifications with our applicators. It allows us to determine that they maintain the trained personnel, the equipment, and the knowledge to repair these tanks and infrastructures.
Somebody wrote in, do you have chemical resistance coatings? Yes, we do. As a matter of fact, on our website, our R&D department does a fantastic job of putting together a list of chemical resistance on each coating to see what they hold up to. And honestly, if that chemical is not on there, we're small and nimble enough to be able to test exactly your cargo to find out what's the best fit for your project.
Do coatings on the outside of a potable water tank need to be certified NSF Standard 61? No, they do not need to be. You need to certify your coatings and linings that are in direct contact with the water.
Did any of these projects result in loss of water service to customers? Yes, while the tanks were down, there was a little bit of a capacity loss, but typically they bring in a temporary water source, whether it be an outside tank or some way to be able to keep their service going. There might be a capacity loss, but I mean, there's usually not a shutdown completely. That depends on the system and the project itself. The question goes on to say, what was the time frame for tanks being OOS? I'm not familiar with that.
Out of service.
Oh, out of service. I apologize. Time frame. Well, like the Devil Tower one, they had 6 days to put it right back into service, which was the result of a great coordination with the general contractor and the coating contractor. You know, the system was applied in a matter of just a day and a half. The contractor and the coating contractor and general contractor got to work real close together to make things coordinate and work.
The Wilson time frame on that one being coated, which that tank was down, so it wasn't a concern. That tank stretched out about 3-week mark. That was because of removing the calcite. They had difficulty blasting that calcite off, removing it, cleaning the tank. As you can tell from that tank, with all the rusted rebar, they had to repair the rebar. There was extensive work involved in that one. Exact time frame, I'm not familiar, don't remember it, but it was around the 3-week mark. The Telluride tank, that one, whenever we got on site, the Hypalon liner was removed. They had a tank next to it, so it wasn't a huge concern. It stretched into about the 3-week mark also. There was some weather issues on that one, that getting up to the tank when it snowed was nearly impossible.
Question came in as, what are the most common failures in protective linings? Delamination of the lining or premature rust corrosion is probably the most common. It's most often due to improper surface preparation. There's a lot of good coatings out there. Properly written, thorough coating specification, and obviously the surface preparation being done is really the most important part, for a key successful lining install. So there's many different things, but that's probably the main premature, or the most common failures are the rust corrosion premature, or the delamination of the lining. And all that usually typically happens within the first 12 months. The common problems of a coating failure will usually rear its ugly head within the first 12 to 18 months.
Okay, that looks like we've covered most all the questions. If we did, scrolling back and forth through there, miss one of your questions, we will answer all of these questions and send them out to all the attendees. With contact information, you can contact us directly if you have any extra questions on them, if we don't answer them completely.